high momentum rotary type nozzle. And a big part of the basic fire. This table here really illustrates what drives this technology. It's just basically water is what drives this technology, or very little water requirement. So you compare hydrocarbon application, non-distilled liquid, gives scientifically 1/16% concentration. CAP system only requires a minimum density of 0.04 ppm per square foot. That really is the part of why you have to develop these systems. The FM approval is requiring only 2% concentration compared to 3%. So if you look at the hydrocarbons using 4 times less water, 6 times less water. We're using the same foam concentrate, which is off the shelf, into the left. We're using natural foam. They're only 2%. We've recently received an enhancement in the FM approval on mystical liquids. That was an important development as well. This came in 2006. By reducing the nozzle spacing in the liquid like concentrate and alcohol concentrate, we were able to successfully pass the L162 at density of 0.06. So again, we're maintaining that 4 times less water average. For those of you who involved in getting that fire protection, really rare, but at least we're really much more severe job environment around it. Water soluble liquids, alcohols, ketones, acetones, typically designed to 4.6 sprinklers. Look at the way sprinklers are listed, phones, specific sprinkler average, specific density, specific fuel. CAP system, we're designing a 6% concentration instead of 2%. And that again is just because of the sheer nature of this liquids. But if you look up with the water, taken into consideration, we're still using half of the foam compared to full nozzle. This is a nice couple nice photos that should illustrate the difference in the consistencies of the foams. On the left, you see a spring spill fire test at NRC. We had it obstructed. People on the NFP11 foam that we were questioning because of our thicker foam blanket or the higher viscosity of foam that people would they were questioning how it would behave in a obstructed situation. And we proved through this fire test, the spill fire test, where we had a continuous flow of heptane on the concrete slab in the envelope, that we would be foam meant to fall underneath that obstruction and extinguish the fire. And you can see as well, we're providing a very uniform foam blanket as compared to your left. Because of the higher water volumes and the turbulence caused by the sprinkler discharge, there are openings which are created in the foam blanket, and that potentially will expose the fuel and potentially cause problems with this compression.
These bridges were taken roughly the same time.
That's correct. Yes. These are the 3 main categories of full-scale fire tests that are within the scope of the FM approval. I'm still using D1-162 as the test protocol to improve foam systems. We're actually in the process of developing our own standard, and I understand they're developing their own standard for gas compression systems as well. So we did the D1-162 test. We're not going to have time to look at that today, but if you have a CD on our website, it's available to download. If you want to view that fire test video, essentially when you're coming out with new technology, you want to see how it performs in comparison with existing technology. So this fire test provides side-by-side views of the CAP system and the water sprinkler system. So this is the pool fire test. The spill fire test is on a concrete slab. It was based on the well-162 in that 5-minute period. The So, and we had George Cranton here, who was heading up the research project at MSC.
Well, it's been pretty cool, so
Yeah. Absolutely. The most difficult portion was the cascade on the front of the transformer. And this is what led us to the effort of approval on cascading type fire. I just want to make sure everybody's clear, this is not a three-dimensional fire. Okay, we're not doing 3D fires. It's a 3D hazard. It's not a 3D fire. If you read NFPA 15, the intent of the welding spray system is to control fire although the failure system did actually put out the fire, it took almost 4 minutes as compared to a minute and a half for the CAF system. But if you look at the big differences on the water, 240 ppm versus 42, to full extinguishment, we flowed 940 on the deluge system. The CAF system only requires 63.5 gallons of water and run at a 30 gallons of foam concentrate. Came full extinguishment.
Well, I think it's pretty well.
It is. The effort approval for a local application is 5-minute duration. Okay? So this type of transformer, you're looking at a 5 or 10 gallon foam tank. Yeah, this was like a cutaway, like I said. So the full transformer would have been double that. It would have been 44 nozzles.
Yeah, exactly.
So it would have been 480, so 500 gallons per minute.
I don't think you would ever have thought of Patriot leverage sticking to the side of the transformer.
No. That's one of the big advantages of the CAF is the adherence. It basically sticks to all vertical surfaces, horizontal surfaces, so it also provides for good thermal protection. Everything comes in contact with. And I wanted to show you some of the system hardware that we're using. As you can readily see from the slide here, we're still, applying our integrated philosophy to the system. The whole idea is to take the mystery out of how these things get put together and installed. Everything's pre-assembled and tested in the factory, just like a total pack system. You've got 3 main components: the cylinder banks, provide them in high pressure cylinders and cylinder banks. The foam tank is a pressure vessel, not a bladder type. And all the controls are in a cabinet, and we have an approved releasing controller as well. Module of that cabinet. And we also supply the nozzles. The contractor will supply the piping obviously to the system. Fireflex supplies the interconnecting pipes between the 3 main components that you see there.
What kind of viscosity does it have when it flows through the premix? The mixed solution flows through the system. How does it compare to water?
The delivery time is approximately the same.
How does it flow? Do you go
water supply manifold, just like the flow pack, as well as the drain manifold, you can come in by the recycle cabinet. Minimum water pressure is 50 psi. So at 50 psi water pressure, residual, you can work with that. You can have up to 3 mixing chambers per cabinet. We've done one project where we have 3 mixing chambers, although they have to be smaller than the sizes that you see up there. Essentially, a 3-inch mixing chamber will supply the we also have a manual station as well as all panel is a fireplace panel. Well, the analog releasing controller. It's fully integrated microprocessor based. Everything's factory programmed. It's got a nice LCD display as well. Easy to work with. One of the important features of this panel, because of our past experience with hydro, we have access to their EMI test lab. So for electromagnetic interference, they tell me this panel is they tell me it's the most resistant panel for EMI resistance. And that's something important. The last thing we want areas. The panel is fully programmable, expandable as well. We have power comparators, we have ways and battery, emergency batteries are way down there. The storage tank is a pressure vessel. It's normally non-pressurized, normal standby. Stainless steel tank, and it's got gas inspection. Typically, the tanks range from 5 gallons to 500 gallons plus. When you fit all where they're at, tanks, where it's using standard ball system, you don't run out of 4 or 6, I should say. Tanks are rated to 150 psi maximum working pressure. So you got the air supply inlet. Excuse me. You got a relief valve, pressure relief valve, set at 150. Like any tank, you got a psych tube, and we have a siphon tube in the middle. So the air supply, we're using the system air to get the foam out of the tank into the mixing chamber. So upon activation, the air supply is going to the mixing chamber, but it's also going to the foam tank to get the foam out of the tank. The nominal air pressure is 100 psi. We're regulating that air supply down to 100. We can also work with a situation we have absolutely no water supply, and in the same way, we can have a water tank, use the system there, and also get the water out of the tank into the system. We've actually got a building in the computer right now, provided the water tank as well. These radios, yeah, we're not waiting to do that. Pardon me? The air supply is provided in the high pressure cylinders. We look at high pressure compressors. The problem with compressors is they're very expensive. We couldn't find one that had any level listening to fire protection. So this seems to be the most economical, practical way to go. The air cylinders are 2400 psi. All the valves in the cylinder heads are open. We have a high pressure manifold, pressure regulator. We've got a single refilling port, which is nice. We monitor air supply 24 hours 7. We can know a day in advance. There's a small leak. There's going to be potentially an air supply problem. We can know 24 hours in advance. So we're monitoring the air supply, very important air supply, because what air is going through. So after rain, basically, we have 2400 psi, high pressure this sealing nozzle activates, so you get that rotary action, and you get that even distribution and that uniform foam blanket. You can see how that nozzle broadcasts the foam fairly well across the floor area there. This was taken during the UL 162 distribution test. The piping, very important. The system is a balanced piping system. Okay. Don't forget, this foam is like shaving cream. It's very light. Kind of behaves like a gaseous extinction system. We need balanced piping. Those designers who are here, that just means using full head feeds, equivalent lengths of pipe at a T connection, equivalent size and length. There is some flexibility built into the program, but we just don't publish it. This is a 32 nozzle layout. So you got a 4-inch, you got your system, you have a 4-inch main, you just get a 4-year life long, black sprinkler pipe, galvanized. The system itself is like. Obviously for maintenance, we keep space between the cylinder banks. You can easily get in there and pull those out if you need to. I think the cylinders have to be discharged every 12 years. Water supply tanks were indoors, they were 2 times 7,000 gallons, which was much less than it would have been. They used 1,000 gallon water pump. When you're there, water tanks are otherwise, I don't think you call it. So you're talking about fuel aircraft, water won't extinguish a flammable or combustible fire. And aircraft hangars require redundancy. You have an electric fire pump, you need a backup diesel. And then you start calculating the infrastructural requirements of the fire protection for hangars. The system, makes good sense in these specific situations. Again, we did a 2-minute discharge test. We had the initial coverage on the floor, and after the 2-minute test, we had the coverage. All right. We can wrap this up now. Basically show a demonstrated where the systems can be applied and some of the projects we've been involved with. Maybe wrap it up. Let's just look at a little cost. We can talk about technical issues. It always comes down to cost as well. We have a couple more hangars we've been involved with. 2 of them actually the same, very, very much, a carbon copy of the other. One's in Quebec City, one's in Vancouver. This is based on the BCIT hangar in Vancouver, 45,000 square foot one hangar. This is what the phone system would have cost. The problem they had, they only had a 10-inch head in the 45,000. And the infrastructure upgrade again would be enormous. The infrastructural cost would have been almost 3/4 of the entire project, fire protection. Look at the cost of pipe, and then look at the ICAP system. System hardware for the system, we've got air, the air supply, so the CAP system is more expensive than a system. We're not trying to deny that. It's just in these certain circumstances, when you can reduce the infrastructure by over $500,000, or actually even more than that. They say they saved on the overall project close to $1 million with the CAP system. Net savings of 35%, and that's just because of the water supply requirements. Doesn't even take into account the payment system. Supply chart there was maybe we talk about the payment. So when do you use ICAP systems? You have water supply issues. Water is what drives the application of this technology. When you can reduce or eliminate large water tanks, huge fire pumps. On the other end, when you have, once it's discharged, you have to do something with it. You have inadequate drainage, containment issues, high disposal cost of cold water. And you can probably vouch that the environmental people aren't allowing us to discharge less than the environment anymore. Most of them. So you have to verify with your local jurisdiction very good quality foam. Sometimes you can get explosion in the nozzle. I don't know how they did it, I was never witness it, but the drain time was 3 minutes and 30 seconds.
The thing is,